All right, this is Math Skill Builder number 9. These questions on the SAT are all what are called constructed response or gridded response. So there's going to be no multiple choice options on these 5 questions. So first question says a video game was released with 4 playable characters. Video game company has a plan to add 6 new characters every quarter, which is 1/4 of a year or 3 months for the first 2 years. So if you have an equation that's written in the form y equals ax plus b, to represent the number of characters y released by the video game after a certain number of quarters x has gone by, they want to know what is the value of b. So this is a question that's completely assessing your understanding of slope-intercept form of a linear equation. There's lots of numbers in here, 4 playable characters, 6 new characters every quarter. They tell you that's every 3 months for 2 years. So lots of numbers. But important thing to know is, what does b represent in slope-intercept form? So here they're using a, where we're used to seeing m, and that's our slope number, which is the rate of change. B is the y-intercept. A way to think about that is, what is the value of this function when x is 0? So if 0 quarters have gone by, they've not added any new characters. It's how many they started with, which is 4. So in this case, b is equal to 4. Let's check our second item. So we've got an equation, 5 plus x plus another x minus 5 minus 1 equals 9 plus x. And we're asked, what is the value of x in this equation? All right, so it's a little more complicated equation than we're used to seeing, but recall what this tells us is, that's 5x, by the way, that we need to combine some like terms. So 5x plus 1x is 7x, and then constants are automatically like terms, so a -5 and a -1 is a -6. Right? So now we've got an equation that has variables on both sides. We're going to pick one or the other of the variable terms to eliminate. Doesn't matter which one, right? And we're going to use inverse operations to do it. Traditionally, we pick the one that's less than as far as coefficients. 1x is less than 7x, so I'm going to subtract 1x because that undoes addition of 1x. So 7x minus x is 6x minus 6 equals 9. So 9 and 6 makes 15. So in a constructed response on the SAT, you'll have a couple of options here. You have x equals 15 over 6. Now, you're not allowed to put in a mixed number, right? So you would reduce this. 6 and 15 both divide by 3. So you could say 5 over 2, or 5 over 2 is equal to 2.5. So either one of those answers would be acceptable entered on the SAT. Awesome. Let's take item number 3. All right, we've got a system of equations. Y equals 3x plus 2 and 6x equals y. And we're asked, what is the y coordinate of the solution? Okay, so solution tells us we need to solve. We need to solve a system, and we're specifically interested in what is the y coordinate. So you know that you have multiple ways that you can solve a system of equations. One of the ways is known as substitution, and I'm looking at this. Both of these equations are already solved for y. If I have just one equation solved for one variable, or can easily be solved for one variable, then substitution is pretty straightforward. And because it's a system, whatever these y's are, they're the same. So y is always equal to y. This has the same value as y because this equation says so. This has the same value as y because this equation says so. So if they're both equal to y, they're equal to each other. So that's how we would set up this equation. Same story like you did in number 2 now. Okay? Equation with variables on both sides. So this is our x value. So don't stop, because we've kind of trained ourselves. Hey, if I get x equals a number, I'm good, I can move on. But in this case, the question is asking us, what is the y value? So I know that y is equal to 6x. X, we just found out, has a value of 2/3. So 6 times 2/3 tells me y is equal to 4. All right, two more. Here's item number 4. So we're told that Phil is working as an extra on a TV show, and he earned $10 per hour for the first 15 hours that he worked this week. They thought he did a good job, so he got a bigger role and more money. He raised his salary to $30 per hour for the rest of the week. It says that he saves 50% of his earnings each week, which is half. What is the least number of hours he must work the rest of the week to save at least $300 for the total week? So the first thing we want to think about is, how can I express the money he's earned mathematically? So he's already worked 15 hours at $10 an hour. Now he's going to make $30 an hour for some unknown number of hours. And that's going to equal his total pay. Okay, great. So if that's the case, let's see what's going on here. 10 times 15 is 150, plus 30 times x. All right, he's trying to save at least $300. But recall that that's half of his total pay. So if these two things add up to his total pay, and we took half of that, we need to double that 300. So 150 plus 30x equals 600. Now solve. Right, so if we do 450 divided by 30, 45 divided by 3 is 15. So we saw that if he works at least 15 hours for the remainder of the week, he'll be able to save half of his pay and have that be equal to $300. Okay, last one. All right, we have x equals 9/5 y, and we're told y equals 10. Then the question is, what is 3x minus 8 equal to? All right, so we're given an expression that it contains x and y and a value for y. So the first thing we're going to do is go ahead and substitute in that 10 in place of y. So 10 times 9 is 90, divided by 5 is going to be equal to 18. Excellent. So now they're asking us, what is 3x minus 8 equal to? We now have a value for x. 3 times 18 minus 8. So 3 times 18 is 54. And we get a value of 46. All right, good work, and we'll see you again next week.